Welcome back, everyone. So in this video, we are going to talk about ambiguous grammar. So as we have seen in the previous few lectures, we have discussed context-free grammar. We have discussed about parse trees and derivations. And we saw how we can apply the production rules and make a derivation to check whether a particular string belongs to that language or not. Now, the grammars that we talk about may have certain issues. Okay. So suppose I have a grammar of this type. This is our operator grammar that we had seen earlier. So say E plus E, or E minus E, or E into E, or E divided by E, and ID. Okay, so I'll keep it at this. So in this grammar, this is for evaluation of this is the grammar for arithmetic expressions. So here, suppose I have a string of this type. Okay, ID into ID divided by ID. So I want to have a derivation, or I want to create a parse tree, or I want to have a derivation for this string. So let me draw a parse tree for this. So I start with the symbol E, start symbol E. Okay, so I can apply any of the different productions that we have here. All right, so let me apply this production. So what I'll do is I will use this E into E. Okay, now let me draw the leftmost parse tree, leftmost derivation. So I will reduce this to ID. Okay, because I'm using this production. Okay, then what I'll do, I'll expand now this. This is the next one which is left. So for this, I will apply E divided by E. Okay, then again, since I'm doing leftmost, so again I will take this, I'll put ID here, then I'll put ID here. So I have got, if you traverse this tree, you'll find something like this. All the leaf nodes, if we write it down, I'll get ID into ID divided by ID. Okay. Now let me have another derivation for this. For the same tree, let me draw another parse tree. Let's see if it is possible. So again, I start with the start symbol E. Okay. And now instead of using E into E, I use this production. E divided by E. Okay. Now again, I'm doing a leftmost derivation. So I take this leftmost and then I expand it like this. E into E. Okay. Then I expand this ID. Then I expand this ID. And then I expand this ID. Okay. So you can see now, again, if we traverse this tree, you'll find it's the same. The yield of this is the same. That is ID into ID divided by ID. So in both the trees we have been using, in both the parse trees, we have been using the leftmost derivation only. Always I have been replacing the leftmost non-terminal at every step. But still I have got two parse trees. Now if you recall that in a parse tree, in a parse tree, if I can have either a I can have a leftmost derivation, or I can have a rightmost derivation. But in this case, I'm getting two different parse trees for the same uh, expression, for the same string. So in that case, my parser, if I design a parser for this grammar, then my output may differ. I may get either this first parse tree, or I may get this second parse tree. So now, which one would be the correct one? Now, if you look at if you think from the expression evaluation point of view, if you look at the first parse tree, you'll see what will be done first. First, division will be done. Okay, because here you see, to perform this multiplication, I need an identifier. So I have this one operand here, and the other operand must come from this side. So to get this, first I have to evaluate this expression E. And to evaluate this expression E, I have to go down the parse tree, and here I have to evaluate E, that is ID divided by ID. So first what will be done is division. Whereas in the second parse tree that we have here, I have to first get E here. So to get E, first I have to do the multiplication. So here I will get ID into ID. So first multiplication will be done, and then the division will be done. Now, if you know the rules of evaluation of expressions of the operators, then you will know that this is nothing but associativity. Okay, so the associativity here is different for the two parse trees. Here, first division is done, and here first multiplication is done. So as a result, the expression will be evaluated in different ways. So we don't want that to happen. So if you have a situation like this, that means for the same parse tree, for the same string, let me just write it down. For the same string, we get more than one leftmost derivation or rightmost derivation, or you can say, or leftmost parse tree or rightmost parse tree. A parse tree where we are doing a leftmost derivation, or parse tree where we are doing the rightmost derivation. So if we get, for the same string, we get multiple parse trees using leftmost derivation or rightmost derivation, then such a grammar is known as a ambiguous grammar. And with ambiguous grammar, we cannot create a parser, or we cannot have an efficient parser using an ambiguous grammar. Okay, because at the end of the day, it is a program, and for this program to work properly, it has to give you, for one input, it should give you one output. So this grammar is your ambiguous grammar. Now, if you go back again, if we go back here and see, now here you have multiplication and division, both have the same they have the same precedence. Now, sometimes in expressions, you may have two operators which have different precedence. So there also it will matter whether which one will be done first. Whether, say, I have a expression like this, I have my operation is like this, ID plus ID into ID. So again, if I try to draw a parse tree for this, I can write it like this, because there's no restriction what I can do first. So this can be E, or this, I will reduce this here, ID. Then here, this will be E into E, ID and ID. So all we are doing leftmost derivation. Okay. Now here, multiplication will be done first, then addition will be done. Okay. So which is okay. But if I write it like this, E is E into E. There's nothing stopping me from using this production. Okay, so then I expand this E plus E. Okay, then I expand this ID, and then I expand this. So here also for the same expression, I have two parse trees. And now the problem is appearing because of the precedence of the operators. Precedence of the operators. So multiplication should have higher precedence than plus. So multiplication should be done first. So this is the correct parse tree, whereas this is not. Okay, but our grammar does not tell me, does not restrict me rather from creating this or generating this parse tree. Okay, the same goes for in case of our here multiply and division. They have the same precedence, but there is something called associativity. So the associativity will decide which will be done first, multiplication or division. So as we know, multiplication and division both has the same precedence, but they have left associativity. So it should be left one should be done first, then right one should be done. So first multiplication should be done, then the division should be done. So again, our grammar that we have here does not make any restriction as to which one of the two parse tree is the correct one. Okay, so now what we have to do is we have to now find out a way of removing this ambiguity that is happening in our that is being present in the grammar. So to remove the ambiguity, we will discuss in the next video what is to be done.